Good morning, class 9 students. I'm sure you are solving all the questions that are given to you every day, and you are doing well in understanding all these classes, and you are also working your assignment in time. And if you are doing all these things, then I'm sure we are also doing, or we are improving on every lecture that is given to you. And you are also doing your work, then this really makes sense for these online classes. Okay, if you remember, I gave you 1.3 as a homework, and if you have done it very good, let's discuss the questions. We are doing question number 5. What can be the maximum number of digits in the repeating block of digits in the decimal expansion of 1 by 17? Perform the division to check your answer. So he is asking us to divide number 7 5. He is asking us to divide 1 by 17. You should try this, and I just tell you there will be 16 digits only, then it will repeat. And because the rule is whatever the number is here, not for everyone but just for this one, the rule is the number of digits can be up to whatever number we are dividing minus 1. So 16 digits this is the maximum number. Sometimes it is less. For example, 1 upon 3, there is only one digit which is repeated, 0.333, and 3 minus 1 is 2. 2 is the maximum number, though we are getting just 1. So the digits can be up to 2 or less than 2. Here the digits can be up to 16 or less than 16. But if you divide 1 by 17, you will find that the digits are exactly equal to 16. So that is the idea behind this question. So you will have to do the long division. All of you know how to divide 1 by 17. I'll just do few steps. Put a decimal 0. It is not dividing. Put a 0 again. Okay. Subtract 0 from here. You get 10. And now you can write 100. And you know it is what? 17 6 are 102 and 17 5 are 85, something like this. Okay, 15, and then you put one more 0, and then you write 17 8 are I think 136. You can check. Okay, 14 140, and then 17 again 8 are we getting 136, something like this. Okay, we are getting 440. I'm writing 40 here. Okay, 17 to the 34, we are getting what? 660. 17 3 are 51, we are getting what? 9 19. 17 5 are 85. Okay, so here it is at this step it might appear that 5 is repeated, but let's check. We get 50 again, and 50, if you know, 17 twos are we are getting it. 5 8 is 5 2, not repeated. So 34, then we take 160, then 17 8 the 17 9 is 153. 153 we are getting, again it is not dividing. 70 17 5 4 the 68, we are getting 20 here. Then again we are 17 1 the 17, we are getting 330 here. Then 17 1 the 17, we are getting 13 here, 130. Then 17 17 what? 17 7 the 119, we are getting 11 here. Then 17 6 the 102, we are getting 8 here. Then 17 17 4 the 68, we are getting 4 here. Then 120, I'm writing here 120. Then 17 7 the 119, we are getting 10 here. And now see, have I written 17 7 here, and now see what is happening. Just 1 is remaining again, and we are getting 10. So I am sure we will again get 0 and then 5. From this place it starts repeating. From this place start, let's count how many digits you have calculated now. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, exactly 16. You can put a bar here. This is how you do the long division. I'm sure you must have done it. So easy to understand. Next question. Question number 6. Look at several example of rational numbers in the form P by Q with no P and Q are integers with no common factor other than 1 and having terminating decimal representation. Can you guess what property Q must satisfy? He is saying that if you have a rational number P and P upon Q, and P and Q have no other common factor other than 1, that is, you can cancel them out, and q is not equal to 0, then he is asking what property q must satisfy in order to be terminating decimal. So I tell you the property here. The property is that denominator, if you suppose I write here 1 upon 2, this is terminating, okay. 1 upon 5, this is also terminating, okay, and 1 upon 10, this is also terminating. So you will, what property this 2, 5, 10 satisfy? You will find that whenever you do the prime factors of 2, 5 or 10, either you will have 2 or 5, or even in 10 if you do the prime factor 2, 5, 5, 5, you will only get 2 or 5. So if you are getting 2 or 5 or both 2 and 5, so I am saying if you get 2 or 5 or both 2 and 5, then it is terminating. Then it is terminating. And if you get any other prime factors then other than 2 or 5, it is non-terminating. For example, 1 upon 21 will be non-terminating because the prime factors are 3 and 7. Okay. Similarly, if the prime factors are 1 upon 6, the prime factor of 6 is 2 and 3. This is also non-terminating. 2 is there, but 3 has come. There should be purely 2, purely 5, or purely 2 and 5. Then only it is terminating. Okay. We'll do this one in detail in class 10th also. So you can just know this much till now. Then it's saying write three number whose decimal expansion are non-terminating and non-repeating. Non-recurring matlab non-repeating. Okay. So 3 decimal expansion. You can write any decimal and then just try to understand that. You can write as many as you want, like 0.123. Okay, nothing should repeat. 4, 1, 1, 0, 0, 1, 2, 1, 3, and then you put dot 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 dot. Dot 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 reference non-terminating. Just make sure nothing gets repeated. Write anything you want. 1, 1, 2, 2, 0, 0, 5, 7, 2, 3. No pattern. You cannot put a bar on any number that this pattern is repeated. For example, in 1 by 17, we know after 16 digits it repeats. But here you should just make sure that nothing repeats. Put dot dot dot. 0.27325670057 dot dot dot. This way you can write as many answers as you want. Okay. Then write 3 numbers whose decimal expansion. Find 3 different rational numbers between 5 by 7 and 9 by 11. So and 9 5 by 7 and 9 by 11. Okay. So let's see 5 by 7 and 9 by 11. Suppose you have 5 by 7 here and 9 by 11. Okay. Now see 5 by 7. What is the decimal of 5 by 7? This is also non-terminating. This is also non-terminating. So you need to divide them and find out. So divide 5 by 7.0. You get what? 7 7 the 49, and then you get 1. So you get, so it's approximately 0.71. There are more digits, but we are just writing 2 digits. 9 divided by 11. 0.0. 11 8 88, and then what is left? 2. So this is approximately 0.81. Okay. So we just write there approximately decimal 0.71 for this and 0.81 for this. And now he is asking write 3 different irrational numbers. So the same way that we have written in the previous question, start with 0.71 and increase the digits, say 72. Okay. Now 1 2 3 5 6 0 1 dot dot dot. Start with 73 2 3 5 0 2 0 1 dot dot dot. Start with any number 74 up till 81 you can go 0 0 1 2 3 4 5 6 0 0 dot dot dot. These are 3 irrational numbers between 0.71 and 0.81. These are approximate values, but then these are also non-terminating and non-repeating. Okay. Classify the following numbers as rational or irrational. Root of any number is irrational, but if it is a perfect square, then it is rational. So root of any number is irrational. So we are looking at question number 9. Okay. First one is root of 23. Now root of 23 is what? Irrational, because it is not a perfect square. Okay. Second one is 2 to 5. 2 to 5 is a perfect square. If you do the prime factor, you will understand. So this is rational because this is equal to 15. Okay, 0.3796. 0.3796. This one. This is a terminating decimal. Terminating decimal is always rational. Terminating decimal is always rational. 7.478478. 7.478478. This is repeating because you can write 7.478 bar. This is if it is non-terminating repeating, then also it is rational. And then you have 1 point, the next one, that is fifth part, 1.101001101001001 dot dot dot. Nothing is repeated and it is dot dot dot, non-terminating, non-repeating. This one is irrational, right? So if you have not understood anything, rewind the video and watch it again so that you understand all the questions one more time. And then I am just asking you to complete this much only today. So this is again the homework for you. Do it again properly, the exercise. Understand till this much so that your concepts are clear. Then we will start with the next topic in the next class.